move on to the preparation of acids. This is not new to us at all. So it's just a refreshing or recap of whatever we have learnt earlier. The first preparation is direct combination. When 2 or 3 elements are combined together to give a new one, that's called as a direct combination. For example, hydrogen can combine with chlorine to give hydrogen chloride. That is direct combination. And the second one is whenever we take non-metallic oxides and add water to this also results in acids. For example, carbon dioxide, carbon is a non-metal, oxygen added to it is a non-metallic oxide. To this when we add water, this gives you carbonic acid. Sulfur dioxide plus water would give you sulfurous acid. Sulfur trioxide plus water would give sulfuric acid. So you are just literally adding a non-metallic oxide and water together and you get the acid. That's the second method. The third method is when you have a less or non-volatile acid reacting with one salt, this gives you a volatile acid plus another salt. What's happening? The non-volatile acid displaces the volatile acid from its salt. It's just a displacement, a change of place. For example, if we take sulfuric acid concentrated, when this reacts with sodium chloride at a temperature less than 200 degrees, then we get sodium bisulfate plus hydrogen chloride. Okay, so this is the displacement method. The last one is when sulfur reacts with concentrated nitric acid. This is slightly different. You get nitrogen dioxide plus water plus sulfuric acid. 6H2 and 2 here. Here you see there is a shift. Here non-volatile giving volatile acid. Here what's happening? This nitric acid is volatile. This gives us a non-volatile or least volatile acid. So these are the different methods of preparation. Now we move on to the properties of acid. All of us have tasted fruits. I'm sure there's nobody who says, I don't like fruits. When you take fruits, the first thing that comes to your taste bud is, it is sour to taste. All acids are sour to taste. That doesn't mean that you have to go and try sulfuric acid and hydrochloric acid. I know all organic acids we know. So from that you get that hint that they are sour to taste. Okay, that's the first one. Second one is, whenever you introduce litmus paper, blue litmus will turn red. This is a very important thing about the acids. Now, when we take some acid, and take a blue litmus paper, now this is blue in color. Now, when you put this inside, it turns red. Okay, so this is the experiment, this is the first test that we could have for an acid. It turns blue litmus red. The next one is, when you talk about hydrochloric acid or sulfuric acid, your teacher would immediately tell you, don't touch that, don't touch that, don't touch that. Why? Because it is highly corrosive. All acids are highly corrosive. What does it mean? See, sometimes sulfuric acid can even eat up concrete. When we kept it in one of our labs earlier, the concrete was completely eroded or rather corroded by sulfuric acid. So these are the very important properties that it has. Now we move on to the chemical properties. These are physical things that we see. Now we move on to chemical properties. What do these do? Acids basically undergo neutralization reactions. Let us just recall what is neutralization. When it reacts with a base, it gives you salt and water. This is an acid that reacts with a base like sodium hydroxide, that gives you a salt, sodium chloride, and water. That is called as neutralization. Next is, it reacts with active metals to liberate hydrogen. Actually, what is happening here, say let us take zinc or magnesium. When this reacts with dilute hydrochloric acid, this would give you zinc chloride and hydrogen. And when this happens, it is always accompanied by brisk effervescence. This brisk effervescence usually is just similar to what we see in the when you open a soda bottle, what happens. So, or when you open anything like any soft drink, especially you children, you like to shake it a little bit, and then when you open it, it's still all the more, and it gives you a lot of bubbles, and that is called as brisk effervescence. Now we would try one of these active metals, and when they react, when it reacts with dilute hydrochloric acid, you can see bubbles coming up, and this bubbles actually is nothing but evolution of hydrogen, and this happens, this is called as brisk effervescence. Now what is actually happening here? If you see here, this acid has displaced hydrogen and zinc has come into its place. So it's actually undergoing displacement reaction. This reaction is called as displacement reaction. Okay, that's the second property. The third property is it can react with so many things, like say it can react with carbonates and bicarbonates, and it releases carbon dioxide. Okay, so supposing we take sodium carbonate, this reacts with dilute hydrochloric acid. This would give you a salt plus water plus carbon dioxide. Okay, 2 and 2 here, so HCl, yes, it's correct. Now this carbon dioxide will turn lime water milky. Okay, so that's about carbonates, and the same reaction goes for bicarbonate also. Supposing we take sodium bicarbonate, this also reacts with dilute hydrochloric acid. Remember, all these are dilute, to give again sodium chloride plus water plus carbon dioxide. Here also carbon dioxide is formed. So this is with carbonates and bicarbonates. Two more properties is it can also react with sulfides and bisulfides. Okay, for example, sodium sulfite. So what would it give? It would give salt plus water plus sulfur dioxide. That's the difference here. Here it is carbon dioxide, here it is sulfur dioxide. Here you have carbonate, so that releases carbon dioxide. Here it is sulfite. So when this reacts with hydrochloric acid or any dilute acid, it would give you salt plus water plus sulfur dioxide to here and to here. Now the thing with this is sulfur dioxide also turns lime water milky. Then what is the difference between the two? Carbon dioxide, when potassium permanganate is added, there is no reaction, but here with potassium permanganate becomes colorless. Pink color disappears and it becomes colorless, but here there is no reaction with potassium permanganate. So that is the difference between carbon dioxide and sulfur dioxide. The last one that we see here is with sulfides. Okay, for example, if you take iron sulfide, when this reacts with dilute hydrochloric acid, you would get a rotten egg smelling hydrogen sulfide gas and iron chloride. Okay, now this is from the smell we can find out that it is hydrogen sulfide. Not only that, when you pass it with lead acetate paper, will turn black. Okay, so that is the identification for hydrogen sulfide. The last property that we have in chemical properties is again a non-volatile acid or less volatile acid displaces a volatile acid from its salt. This we already see under the compounds, but still let us refresh ourselves. If we take concentrated sulfuric acid, this will displace, say let us take sodium chloride at a temperature less than 200 degrees. This gives you sodium bisulfate plus HCl. Okay, so this is the non-volatile or the less volatile acid, and this is the volatile acid. So with this we finish the chemical properties of acids.